Hi guys, so today what we're going to do is we have a quick review of the Pythagorean theorem. You guys should have done the Khan Academy yesterday, so we're just going to do quick 2 review problems. After that, we're going to talk about the Pythagorean converse and then have practice within this video, and then outside of it you guys will have a Google form with problems to solve along with the second Google form just letting me know. It's a survey about how did you like this mode of learning. Is it working for you guys? Is it not? I know it's just the first one, but I want to know how you guys are feeling about it. So by the end of class today, you should be able to find the missing side length of a right triangle. That's your goal. So in this first example, the skyscrapers shown are connected by a skywalk with support beams. Use the Pythagorean theorem to approximate the length of each support beam. So if we look at this photo, the only piece that's a little bit confusing is the way that they labeled the actual beam. It says 23.26 meters, and that's actually describing the entire length of the beam, not each part. But what we do know is if I sketch out my triangle and I'm thinking about my lengths, my height here is 47.57 meters, and my base would be 11.63. And the reason why I know that it's 11.63 is that notice in the photo, we notice for both support beams, the hypotenuse on each is the same length. And then we also know that the height of each side is the same, meaning that since it's a right triangle, the hypotenuse and one of the legs is the same, we know that their base lengths also have to be the same. So I'm going to take this 23.26, divide it by 2, and I get 11.63. From here, the most important thing to note is that the right angle always points to your C value. So when I use the Pythagorean theorem, I just want to make sure that I make x my C, or what I'm solving for. In the problem, I labeled my A value as 11.63 and my B value as 47.57. But again, you guys could have done it vice versa, and you'd still get the same end result in that 48.97 meters is the length of our hypotenuse. The next problem, a 30-foot telephone pole has a 50-foot support cable connected to the top of the pole and the ground. How far up from the ground should the support cable be from the telephone pole? So again, the best thing to do is to actually draw a little sketch, give yourself a little picture. I know that the pole is my 30 feet here, and then it says that 50-foot cable support is connected from the top of the pole to the ground, and that's 50 feet. Okay, so just making sure that you're labeling correctly your photo, because then that's going to determine what's your A value, your B value, and your C value. And then again here, I want to know the distance from the pole to here. So I'm just going to go ahead and use the Pythagorean theorem again, and I get a squared plus b squared equals c squared. In this case, I gave my a value as 30. Again, you guys could have made that your b value, solve for a, and it would still be the same thing. The most important thing is that my c value is given to the 50 feet, which is what my right angle is pointing to. So the converse of the Pythagorean theorem just states that the sum of the squares of the lengths of 2 sides of a triangle is equal to the square length of the third side, then the triangle is a right triangle. So basically just taking the Pythagorean theorem and stating it in reverse. So what I want you guys to take a couple minutes doing is actually going ahead and sketching out these triangles and seeing what type of triangle is produced with these sketches. So 6 different triangles, take a couple minutes, pause the video, and sketch them. And what you should notice is this. So when our c squared value is less than our a squared plus our b squared, we end up getting an acute triangle. When it's equal to a squared plus b squared, it produces, of course, a right triangle. And then when c squared is greater than a squared plus b squared, we get an obtuse triangle. So if I'm giving you side lengths and I want you to tell me what type of triangle it is without actually doing a sketch, this is the inequality statements you want to be thinking about. But remember, what we talked about, 2 chapters ago, and that you always want to check first, is the triangle even possible to produce? And which, remember, in that case, it has to be that your A and your B value have to be greater than your C value. Because if it's not even possible, then, this question doesn't matter. So go ahead and look at these measurements that I'm giving and tell me, can the side lengths of the triangle actually produce a triangle first? And if they can, go ahead and tell me, is it acute, is it obtuse, or is it a right? So when we look at these measures, this is what you should have gotten. 8, 11, and 13, that one is possible. And if we actually solve it out, 169 is less than 64 plus 121. So it's an acute triangle. Number 2, given those 3 values, just testing it, it's not even possible to create that type of triangle. Number 3,